Thank you for downloading from the BBC. For details of our complete range of podcasts and our terms of use, go to bbcworldservice.com/podcasts.
Space. Vast, magnificent, silent. Well, maybe not so silent. If you close your eyes and listen with the right equipment, there's a lot to hear. I'm Dr. Lucy Green, and over the next 2 episodes of Discovery from BBC World Service, I'll be taking you on a sonic journey across the universe, a trip through space and sound.
You can have sounds in space because space is not actually totally devoid of gas. And what sound is it's a sort of ripple coming through gas, or in our case, air, and then it's picked up by your ear, and so you hear a sound. So because space isn't actually a perfect vacuum, there's absolutely no reason why there can't be sounds made in space.
Some of the sounds that we hear are really sounds, and some of them that we hear are actually what are called sonifications, where we take data, it could be radio observations of space or X-ray observations of things in space, and then you take that information and you transform it into a sound.
Listening to the universe has inspired and informed scientists, artists and musicians. Over the next half an hour, all the noises and music you'll hear have come from our exploration of space. Some have been recorded by microphones on board interplanetary spacecraft. Others have been detected by telescopes and sped up until their frequency is tuned to our ears. The rest are sonified X-rays, space plasma or radio waves that reveal tantalising secrets about the universe that our eyes can't see.
This is Houston, contact with a test. 1, 2, 3.
Our journey begins at the heart of our cosmic neighbourhood, with the nuclear powerhouse that lies at the centre of our solar system.
So this is the sound of the sun vibrating.
Radio astronomer Tim O'Brien from Jodrell Bank.
In this case, we've actually had to speed up those sound waves by a massive factor. They're actually speeded up by a factor of 42,000 in this case, because the real sound waves will be very low frequency, so very, very deep notes, way below the limit of human hearing. And you can sort of understand that in the sense that the sun is a very large object. So just like the very large organ pipes on a church organ play a very deep note, the sun far, far bigger than that, of course, and therefore a much, much deeper note. So in order to hear that, we've speeded the whole thing up to hear the wobbling of the sun, basically, which is quite an incredible thing to think about.
As a solar scientist, I use these sounds to explore a place that can never be seen, the interior of the sun. As the sounds travel through our star, they pick up information about the temperature and motion of the gas inside. This technique is called helioseismology. Now, this is just one single vibration inside the sun, one mode as we call it. But this is what we hear when we listen to several modes together.
There's perhaps millions of different notes that are going on in the sun, millions of different waves that are all oscillating in different ways, vibrating the sun in different directions. So you can choose to sort of isolate one of these particular modes, or you can choose to play all these modes together. It's like having a massive sort of carillon of church bells that you ring simultaneously, if you can imagine that as the whole sun ringing in all these different ways.
It's not just scientists who've been captivated by these solar bells. Artists have also been using these sounds to reveal the beauty and power of our nearest star.
What we're listening to here is a piece by an artist called Caroline Devine called 5-Minute Oscillations of the Sun.
Honor Haja, Executive Director of the Art Science Museum in Singapore.
What Caroline's done here is work with scientists from the Birmingham Solar Oscillations Network, or BISON, who use helioseismology to study the sun. And she's taken this data and used it to create these sustained tones. And this gives us a way of being able to experience the sun as music.
Flowing out from the sun's million-degree atmosphere is a supersonic solar wind. This gusty gale blows out into space, where it envelops the tiny barren world of Mercury. A year on this strange grey planet lasts just 88 Earth days as it races around the sun. But yet during a year, there is only enough time for 1.5 days because Mercury spins at such a leisurely pace around its axis. This sound has been created from measurements taken by NASA's Messenger spacecraft. Here, the solar wind creates waves in Mercury's magnetic field, like wind blowing over the ocean. If you listen closely, you can almost hear the magnetic ripples.
One of the surprising things is that Mercury has a magnetic field at all.
Cosmologist Andrew Ponson from University College London.
In fact, until the 1970s, it was thought that Mercury probably didn't have a magnetic field, because as far as we know, magnetic fields like the one on Earth are generated by liquid cores within the planets. And people thought, with Mercury being a very small planet, that it would no longer have a liquid core that would have cooled down and solidified. But it turns out it does have a magnetic field. It's very weak. And now we think it's probably got some sort of sulfur-iron alloy in the core. The melting point of that would be lower, and that means it can stay liquid even though Mercury has been cooling down.
Onwards now to a more familiar place, the blue planet that we call home. Every day we hear Earth's rich soundscape from the ground, but we can use spacecraft to listen in a new way and discover the invisible world above us. The Earth is unique in the solar system because it's teeming with life. Around 9 million species of plants and animals cover the globe. Protecting us from the ravages of space is a vast magnetic bubble, the magnetosphere. Without it, the solar wind would strip away our atmosphere, which is so vital for life. As the wind hits this invisible shield, it creates what's known as a bow shock.
If you can imagine, the Earth has a magnetic field like a sort of bar magnet, so it has a north pole and a south pole. The magnetic field lines arc around, much like if you ever did an experiment at school with iron filings and a magnet, you might remember this sort of pattern. The sun is blowing out these charged particles. They hit the Earth, and there's a shock wave where the solar wind particles, happily streaming away from the sun, suddenly realise they're about to whack into something, which is this Earth's magnetic field structure, and they're both deflected to one side and they're slowed down. In effect, that protects the Earth from being directly impacted by the solar wind. So that makes this bow shock much like it's like a sonic boom of an aircraft that's travelling faster than the speed of sound.
This magnetic shield keeps out most of the solar wind particles, but some leak in and they become trapped in bands around the Earth called the Van Allen radiation belts. It's from these regions that we begin to hear a strange cosmic chirping, a song that's known as the Earth's chorus.
It's named the chorus because it sounds a bit like the dawn chorus. That's the idea. We have this sort of belts around the Earth where these particles, the electrons in particular, tiny negatively charged particles, spiral around. They produce these radio waves, exactly the same way that, if you're listening to the radio now, those radio waves are transmitted to your aerial by electrons being accelerated in a transmitter, vibrated backwards and forwards, and that produces a radio wave. That radio wave travels across space through the atmosphere at the speed of light, and then it gets to your aerial, and we can turn them into a sound.
Around the Earth's magnetic poles, we find electrically charged particles funneling down into our atmosphere to create beautiful aurorae, the northern and southern lights. But these particles that create such wonderful sights and sounds have a darker side. During geomagnetic storms, this shower of electrical particles becomes a torrential downpour, and this wild space weather can devastate satellites, communication networks, and even knock out power grids back down on the ground.
So we're listening here to an artwork called Black Rain by the artist Semiconductor, and they've worked with data from a pair of satellites called